Senceive webinar. My name is Jackie Jenkin. I'm marketing manager here at Senceive. First off, we're just going to go through a little bit of housekeeping for you, just the normal stuff about webinars. Everyone's obviously in listen-only mode. We're going to take some questions at the end, so feel free to put questions in the chat box, and I'll pop on at the end of the session and I'll read them all out. And this webinar is going to be recorded, so if any of your colleagues have missed the session, don't worry, we're going to email everyone who's registered for the webinar, so not to fear at all. And I'm just going to introduce the presenter of this webinar, introducing Peter Berger. You might recognize him from our last webinar. He was so good in the last one, we asked him back for this one as well. So I'm going to hand it over to Peter now. He's rolling his eyes, but it's true. I'm going to pop on at the end for the questions. So over to you, Peter.
Yeah, Jackie, thank you. Thank you very much. And I always appreciate the sense of humor of our colleagues from marketing. Yeah, welcome to our today's webinar. The topic of today's webinar is from first steps to long-term success, how Senceive supports your wireless monitoring projects. Basically, we will talk about selecting the right wireless technology for your project. We'll talk a little bit about best practice regarding planning and deploying wireless monitoring systems. And of course, we will try to discuss how Senceive can support you through the installation, beyond the implementation, and getting the most out of your data, and in the end have a successful project. You see here the agenda, and we will immediately go into the first topic. Basically, why are we doing monitoring? Well, there are different reasons, of course. So to do long-term condition monitoring of assets, you can do reactive monitoring following a certain event. For example, if you have a problem on site, or if there are heavy rainfalls or events that impact your structure. And of course, you can have project-based monitoring, basically monitoring the influence of your works on third parties. Do, of course, risk management during construction activities, and basically monitoring enables you to follow a very important topic, basically the observational approach, if you want to use monitoring as an input to also modify your design and improve your construction sequence. Well, wireless monitoring is still monitoring. So basically, we still collect parameters with the sensors and our sensor interface nodes from like deformation, tilt, strain, pressure. But there are important things on the site that can influence the decision to go wireless. For example, when you want to achieve a certain reporting rate, wireless obviously comes with some limitations regarding high reporting rates, and we're talking there above 1 Hertz. And of course, it's a question of monitoring duration. Sometimes when you have a very long monitoring project, like a concrete dam for many decades, then maybe a wired solution is still a better option. But sometimes for standard monitoring projects, so if you have just to implement the monitoring solution doing, for example, jet grouting below a track, wireless can be the better solution because you can deploy it quickly and you don't have to take care of cables and other things. And of course, the job site itself, the conditions on site are important to consider. Is it a large or small area? Then it comes down to select the right communication technology from a wireless perspective. And sometimes, on construction sites, you have issues with line of sight that limits potentially the use of a geodetic based system. And wireless comes with advantages on that side. And sometimes you have issues to access site. So manual monitoring is not the solution. And if you cannot access site, or if you have a very remote site, then wireless sensors and wireless interface nodes can still be a better choice. But it's not only, some of our nodes measure something like tilt or distance, but of course we have a high range of wireless interface nodes that are attached to geotechnical instruments that then collect readings regarding strain, stress, pressure, groundwater pressure, soil humidity, temperature, and other factors. And as this year we welcomed our CSGO from Italy into our Edify remote monitoring family, and which is the world leader in geotechnical instrumentation. And now, when you look at all these parameters and also consider the wireless data acquisition side, you have now a one-stop shop where we can provide you with the best solution combining the best of both worlds. I will quickly, I know that a lot of the people joining this webinar maybe know Senceive, but just a couple of slides about what we are doing and some news, of course, that I already mentioned. Well, Senceive is now 20 years, we stand for 20 years of innovation. We have, with our customers, installed more than 100,000 sensors globally in different sectors. We provide support, we provide, sorry, I should have switched it up. We have provided support, sorry, I need to, and yeah, into different areas. We have a local team, we provide global support, and we can provide our solutions, sorry, to subsurface, surface structural projects, and we have also intelligent monitoring solutions like InfraGuard that can help you with specific problems. Good, sorry for that. Yeah, I should have switched off Teams before. Yeah, we have grown out to a team of more than 100 people and from different disciplines, and yeah, provide you then also support in different sectors. And of course, our users of asset owners, consultants, general contractors, and of course I&M companies that might also be part of yeah, the group of people that are joining this webinar today. Well, every project is unique, and different parameters like you know, site conditions, access, environment are important to consider. But there are common challenges like range of the wireless network, power limitations, line of sight that I mentioned already, data integration, or long-term support that are important when it comes to yeah, to wireless monitoring projects. Our goal is to simplify this complexity, and we offer basically two platforms of wireless communication, FlatMesh and GeoOne, and each suits a different environment and different requirements. We will look at the two different options that we have, and choosing the right communication platform is important. When you want a dense network, when you want high frequent reporting, multiple sensor types integrated into one network, don't have mains power on site, so we want to rely on solar power, have intelligent sensors that can react to change. I mentioned InfraGuard already. Then FlatMesh is the right choice because it comes with a intelligent network, a mesh network that is self-healing, that has a large connected because it says I lost my connection.
I think we're okay now, Peter.
Okay, sorry.
Yeah, we're good.
Good. And of course, we have another option that is our GeoOne solution. It's a LoRaWAN-based communication technology that is the better fit for if you want to cover a larger area like an urban area, a large mining site. If you want to integrate a lot of sensors, it's a network where you can connect basically where the node that connects directly to the gateway comes with some limitations regarding reporting rate and does not come with network intelligence at FlatMesh, but can be the right choice if you're looking for covering a larger area in an urban environment or if on a larger mining site. And sorry. And we have also launched a new generation of GeoOne 2 earlier this year. You see here one of the nodes that also come with some features like easy battery replacement and also at a quite interesting price point into the market. And yeah, and this can be one of the two right choices for your solution. But it does not stop here at the sensor level or gateway level. You also need to send the data to a server. You need to process the data. We recently have also launched a Starlink solution for our GeoOne gateways and for our camera hub. But the data, it's important to do something useful and intelligent with the data. We have earlier this year launched Senceive.io, which is our data management platform where you can control your sensor networks, your sensors, and basically expose your data by an API and use it with your own data visualization platform. But we are also in the process of launching Web Monitor 4, the new version of Web Monitor, our data management platform that basically we are quite proud that our technical department is proud to be able to provide you now with a more modern and more intuitive solution also to manage data, provide reporting and alarming functionality. When you look at our website, and we are quite proud of our website and our digital marketing, you can see that there's a lot of focus about sectors, and we talk a lot about sectors, and rail is our most important sector. And in rail, it's about monitoring track geometry, slopes, rockfall, structures like tunnels or portals. Senceive has the right solution for that. We normally recommend the flat mesh solution because of near real-time data and responsiveness of the network. And of course, we try to then also meet the standards of international standards that are important in rail. If it comes to standards like the Euro norms 13848 for that defines basically track geometry, or local standards like the real in Germany 883, where you determine or where you need to fulfill these requirements in order to be allowed to provide solutions to the railway infrastructure. But it's also about infrastructure as another important sector. We have dams, we have bridges, we have other infrastructure like tunnels, and we know that we have aging infrastructure in Europe with more than 10,000 bridges that require repair and maintenance in Germany, in Italy, in France. And this is an important factor, and wireless sensors can play an important role by keeping these assets longer in life and monitor the assets and understand when there is a structural problem, and then they potentially close an asset to avoid the problem that could occur. But also on construction sites, we know that construction sites are busy areas. You have open excavations, you have retaining walls, you have temporary works. We are still lucky that there are investments in urban infrastructure, and when these kinds of projects happen, we always have a very comprehensive monitoring regime. Flat mesh and Geo One can be a useful add-on to this, or can be useful wireless communication technology that they can use in these kind of settings. And I think all are aware of the Euro Code 7 that is basically still defining the geotechnical and infrastructure monitoring and design requirements in Europe. And they define what to do at what stage in a project. And if you implement the wireless as a solution, you can mitigate risks like that cables are destroyed, or that you have no line of sight and that you have to react to changing site conditions. So a wireless solution can be the best option in this case. But also in mining, when you have to cover larger areas, subsurface or on the surface, we know there are tunnel slopes. A big topic are tailing dams. We are quite active in tailing dam monitoring. This is a big topic. We had over the last 20 years several large tailing dam failures in mining at mining sites in Brazil, or also in the US, or in 15 years ago also in Hungary. And it's quite important to have a solution like our InfraGuard solution to monitor tailing dams, but also integrate geotechnical sensors into these monitoring solutions. And over the last years, there has been a lot of progress in defining also global standards for tailing dam management. And the Global Tailing Dam Management Institute submitted this year a new standard how to manage these assets. And it's a quite important topic, and wireless sensors can play a very important role in that aspect. Well, this is a lot of things we have presented also in previous webinars. What we want to talk about today a little bit is our step-by-step approach, because there are companies that are quite experienced with using wireless technology, but we also always have new customers that use wireless solutions the first time. And we follow a certain approach. When we we try to simplify the adoption through a consultative approach. Yeah. And this means we try to understand in the discussion with our customers the challenge. We try to help selecting the right technology, ideally a wireless-based solution. Then we help and provide input by designing the monitoring system. We cannot take the responsibility as we are a manufacturer, but our sales team and our customer support team can help to take the right decision. And then we can help remotely or on site to deploy the system safely and provide support during the project to optimize the data and help you with questions that can happen. And you should not forget what I mentioned earlier. We have a superpower now. We have our friends from CSGEO, who are the world leader in geotechnical instrumentation, and they can help us providing then also the right geotechnical instruments. And this could be any kind from manual inclinometers, in-place inclinometers, piezometers, and they offer a wide range of products. And basically now with Edified Technologies remote monitoring, you have a one-stop shop where we bring these two worlds together and help you and integrate that also into our consultative approach to help you finding the right solution. I want to show now some real project examples, and basically previous webinars we have talked about big rail projects, we have talked about tunnels, we have talked about large-scale projects. I wanted to show you today two projects, one from the rail sector. This is at the moment an active project where we are involved. Basically, the Hanoi Pilot Light Rail Metro Line Project 3. The lot CPO03 is basically responsible to build 4 kilometers of tunnels and underground stations. The joint venture is a joint venture of Hyundai, Gela, and with a subcontractor responsible for the DPM works. And currently, the DPM are approaching Hanoi main train station, and we have been approached by this customer months ago, and they said, well, they have heard of wireless technology. Gela has used our sensors at other projects, and they also wanted to use our sensors to address a certain problem. But how does such a project start? Basically, you get a drawing, and in this case, you have a drawing where we see the two DPM tunnels, and then we see a couple of railway lines, and on the right-hand side, we see the Hanoi main train station. And we discuss what we can do. And when it comes to track monitoring, of course, we then try to offer the right solution. In this case, we discussed the challenge, and we said a flat mesh solution would be the right choice. And of course, we discussed the track geometry requirements. So they are mainly interested, as the DPM is underpassing these 5 tracks in can twist and in the settlement profile. They are not so interested in lateral movement. So on the right hand side, we said, okay, flat mesh gateway, nano macro trackbed node are the right choice. We don't need an ODS for lateral movement. And this was months ago. And then, of course, we discussed lead times. We discuss product certification in new markets, how we can provide local support, what are their reporting requirements, what are their expectations. And it's an iterative approach, especially when it comes to first-time users, how we can support them. We can offer access to our Senceive Academy, where you find useful material to learn how to use our equipment. But in the end, you need to convince the customer that this is the right choice, because you know, a DPM project, it's a time-critical project, and monitoring is important to manage the risk. So after months of discussion, the equipment normally in such a project, if you're successful, is ordered. We did the certification, and of course, normally the equipment just arrives in time to be installed on site before the monitoring is supposed to start. And it's an iterative approach. We then discussed, of course, the number of sensors, the distance between the sensors, the right gateway location, and we help to guide the customers through that. And in this case, they then started the installation. And we have a customer support team, colleagues in the US, in Europe, and in Australia, where we can try to provide 24/5 support. So, you know, Vietnam is 7 hours ahead of the UK time zone. but we sorted it out, and just yesterday I got the picture from the start of the installation on site, and they installed the first two tracks on the left side here, and on each track 7 sensors. Then in web monitor, you then are happy when you see then these 14 active nodes. They obviously have watched the Senceive Academy properly. We advised them properly. They were able to install it. It's also evidence how easy it is to deploy that system. And these 14 sensors have been up and running since yesterday. And last night they installed the next one, and we are now up and running with the system. This is just a nice example where we provide remote support, and yeah, the customer on site can deploy that easily. And when this is then the case, we then guide them through setting up the sensors then in the web platform. In this case, the use web monitor. We explain the data. We help to set up alarms and reporting. We look into temperature compensation in order to improve results. In this case, we have a quite stable conditional site around 25 degrees above Celsius plus, and quite stable. And then, yeah, we have the 29th of November now, and then, as I said, normally things just arrive in time. On the 1st of November, the first DPM will pass below these tracks, and at the moment it looks quite promising that everything will be up and running, and a nice example how yeah, such a system can be deployed remotely. First time customer, as I said, and hopefully right after Halloween, we will hopefully have a first successful breakthrough into the Hanoi main train station box. Yeah, and everything should go to plan. And then I have another example from Germany, from a bridge project. We have heard earlier that that we have tens of thousands of bridges in Europe that require repair, or some also need to be replaced. In this specific case, one of our German distribution partners, Stöcke, won a project with the Deutsche Autobahn AG, and this is a bridge in Bochum, the city of Bochum, the Hernestraße. And this specific bridge is a bridge that sits on rolling bearings with 2 abutments, and well, the abutment walls, it's an aging, very old bridge already, started to move, so there's a risk that the bridge deck could potentially slip off its bearings. Therefore, there was some temporary wooden support installed to mitigate the danger, but of course it still needs to be monitored, and it needs to be understood if there's a potential that the bridge deck would still drop on this temporary support, and it's just a centimeter of distance that need to be observed. So we see here an installation and an interesting customized solution from Göttke. In this situation, there are 8 tilt sensors installed. You see here on the left side one of the tilt sensors. They have been installed on the abutment walls to detect any movement of the wall. If this is happening, there's a risk that yeah, that the bridge slips off and would fall on this temporary support. So that in addition, there was a special monitoring system designed by Göttke to using potentiometric track sensors, and 8 of these devices were installed in order to monitor and find out if the bridge is track is dropping. Basically, it's a binary yes or no situation, but this system allows to observe that, and it's a very successful installation, and also shows that some customization can lead to very smart solutions. And yeah, we as a customer, as a manufacturer of wireless sensors, we cannot always do customization, but we can help. And this is really a nice example how a simple problem was addressed with a quite really nice and innovative solution. Good, 25 minutes, so we stayed well in time. Sorry for the pop-up of my team messages. Hopefully no messages were a little bit, hopefully too compromising. But to summarize, well, wireless monitoring does not have to be complex. I try to summarize the different communication technologies that we can offer, try to provide a quick overview on the sector offerings. Of course, I try to show you our approach, our consultative sales approach. Our sales team is normally, we have experts in different fields, and we are happy to discuss your problems. You don't have to come to us with a your queue and the big project. We're also happy to look into your problems and work together on a solution, just to show you how that works. And the real project examples, just had time for two. I think also show that even a first time user can implement the system far from our office location, 7 hours time difference, successfully, even under quite with some time constraints. Installation started yesterday. DPM will arrive on the 1st of November. And we also, are happy to help our existing partners. We're really happy to have our partners in the different regions, that when they want to come up with a customized solution, we're also here to help. Yeah. Good. In the end, it's about that we want to partner with our customers in order to have a sustainable success of the deployment of our wireless solution. I think Jackie is now back, and I think we still have 3-4 minutes for questions. And
yeah, thank you, Peter. Wonderful, and some really nice case studies there too. We do already have a question for you, and so this one was on platform types and choosing the right platform. So someone's asked, how do I decide what platform is right for my project? And are there any cases where you would use both platforms together in the same project?
Well, I think, as I said, it's always good to talk with our sales team or our distribution partners in the regions. They have the experience to then help you to decide the right platform. As I try to show in the sector part, railway is very much about flat mesh, because of the intelligence of the network of InfraGard that we can offer to monitor slopes and rockfall. When you have to cover a larger area in mining, or also for large infrastructure projects in urban environment, it's always also worth considering a Geo1 and LoRaWAN based solution. You can use both together, but you would still need one gateway communication technology. So the gateway cannot pick up the data of both. And you need to consider that flat mesh gateways can easily run from small solar panels, but with a Geo1 solution, you always need a more comprehensive solar solution, or you need mains power on site. When you are in a tunnel, when you have no cellular connectivity, then potentially the Geo1, because the Geo1 gateway can work on Wi-Fi and also LAN connectivity, and now, as we know, also on Starlink. Then maybe this is an option, or can determine the right or which solution we should use. But flat mesh is I think the more flexible solution.
Definitely. Someone's asked about sampling frequency and what sort of sampling frequencies our products offer.
Well, basically, flat mesh could allow you theoretically to take a reading every second. The usual reporting rate is about a minute, 15 minutes, 30 minutes. Yeah. The battery life, when you use it as a standard reporting rate of 15 minutes, 30 minutes, a tilt sensor can last 10 years. If you go down to 1 second, then of course you need to allow certain things like mains power for the flat mesh gateway, because the gateway then needs to be on all the time. The modem needs to be on, because it's always about getting the data through also the cellular network to the server to then process it. So it is theoretically possible with Geo1, 5 minutes, 15 minutes reporting rate, depending on the number of sensors, is also achievable. But we are not going into the higher frequent dynamic side of things. So this is the limitation, I would say.
This is kind of similar topic, but just about really harsh environments, and does this system actually last for several years in a harsh environment? You kind of touched on this a little bit already.
Well, the sensors have high IP rating up to 68, 69, and when we look at the trackpad nodes that we see that they are many years on track, they still come back for refurbishment and go out after calibration and refurbishment again. When our sensor interface nodes, they come with IP-rated connectors, so we are not wiring, inside the node, the connection to a geotechnical sensor. We have connectors, so this is also an indication for withstanding harsh environments, because you have higher IP rating when you don't have to open a box and wire cables into something and into a board, into a node. So we have an approach where the design of the let's say wireless nodes is more let's say, to withstand harsh conditions. And we know from projects that where we have nodes years on site that they are still working. And I think the best you can do is what we do, I think, with these connections, and normally you should not have an issue.
Mm. We have one last question here, but feel free to keep typing questions as we speak. Someone's asked about satellite solutions, and are we looking at more satellite solutions for node deployment in very, very remote areas?
We have basically two options. We have a BGAN satellite communication-based system that comes with some restrictions regarding bandwidth. So if you have a Tier 1 deployment, a gateway with a satellite modem, you are limited with the number of sensors and the number of readings you take in a certain period of time. We have deployed that in Central Africa and in certain regions. And recently we have added Starlink for Tier 1 and for our camera hub, yeah, which allows you more bandwidth because the Starlink communication is provides just a broadband internet connection, yeah. But it is always important to know the location. It's important how many sensors you want to connect. It's important to know what power, if you have power on site or not, because you need to design a proper solar power supply, which we normally use. You could also use other technology, but we normally go with a solar panel. So we can help with that, and we can offer two different options depending on your needs. In Central Africa, we have deployed these BGAN solutions. In other areas around the world where we have Starlink coverage, we might go now with the Starlink solution that just provides a better bandwidth. Yeah.
Mm-hmm. Great. I think that's it for questions for now. But of course, if anyone looking right now thinks of more questions, feel free to email us at info@senceive.com and we'll get back to you right away. Well, I think we just managed to get there on time. It's 1 minute over, but we think you did pretty well. And
Thank you.
stuck with the Halloween theme.
Now we have a Halloween theme and not our theme messages popping up. So yeah, wish you a happy Halloween. And if you have any questions, please feel free to reach out to us, and we're happy to discuss your projects. Thank you, Jackie, for support.
Thank you so much, Peter. We appreciate it.
Yeah,
Thank you. Have a good rest of the day, everyone. Thank you. Bye.
Bye.